Today's goal is to multiply and divide rational expressions. Again, rational means it's a ratio of polynomials. Expressions are things with no equal signs. We won't be dealing as much with functions and equations. Example 1. Given these two functions, write the function f times g. I know this means multiplication because they're next to each other. So f times g of x in factored form. So to write this new function, I need to take the functions given and multiply them. So I have x squared minus 16 over x squared minus 25 times x minus 5 over x squared minus 4x. Now, one option to multiply is to get a giant box method out here. So I'll need a box method for that here. And then to get a giant box method out here, use the box method. Once I've got all my terms, then try to factor and then simplify by canceling factors that are common to the numerator and the denominator. Now, wouldn't it be easier to just start with everything factored? So I've got x plus 4 times x minus 4 over x plus 5 times the quantity x minus 5 times x minus 5. It's already linear, so it can't be further factored, times x times the quantity x minus 4. Now, if I factor in the first place, I can figure out what will cancel out before I even multiply. Now I've got fewer things to multiply. Now, to multiply fractions, I simply multiply across the numerator and multiply across the denominator. So what do we have left here? In the numerator, we've just got an x plus 4 times nothing, or times 1, just gives you an x plus 4. In the denominator, I've got an x plus 5 and an x that remain. Well, the question asks for my answer in factored form, so I'm just going to leave the x out in front, put the x plus 5 in its factor after that, and this is my function f times g of x. If I want, I can write the discontinuities looking at the original unsimplified version. This is true as long as x is not positive or negative 5, 0, or 4, because those are the values that would make the denominator equal to 0 in the unsimplified version. Okay, let's take a look at example 2. Simplify this expression. Oof. Now maybe this looks nasty to you, but keep in mind this is just a fraction inside of a fraction. And this fraction is the same thing as just a division bar. So what this means is we just have the rational expression x squared plus 7x plus 10 over x squared minus 2x minus 8 divided by x squared plus 4x minus 5 over x squared minus 3x minus 4. And to divide fractions, we know that we can just multiply by the reciprocal. So I'm going to recopy the first fraction, or the numerator, exactly how it was. And now I'm going to change this division to a multiplication if I flip around the second fraction, or the denominator, of my original compound fraction, the fraction within a fraction. This is the one I'll flip. Okay, well now to multiply these, again, I can multiply straight across the top and make a giant 3 by 3 box method where I have x squared plus 7x plus 10 times x squared minus 3x minus 4. But guys, I'm not that cruel. There's got to be an easier way. Oh, right. Well, we can just go ahead and factor. So I have x plus 5 times x plus 2 over the quantity x plus 4. Oops, it's got to be negative 4 times x plus 2 to make this 2 negative, times x minus 4 times x plus 1 over x minus 5 times x plus 1. Will anything cancel? Yeah, we can cancel out any factor that we are multiplying both the numerator and the denominator by. How nice is that? So you end up with just x plus 5 over x minus 5. As long as x is not equal to, again, we're going to look at the denominator of my unsimplified fraction for its discontinuities. The discontinuities would be x equals 4, x equals negative 2, x equals 5, and x equals negative 1. So these are the values that my fraction cannot be. Okay, let's take a look at one final example. Express the function f over g of x in standard form, okay, not factored form this time, given these two functions. Okay, f over g of x, that means I'm just going to divide f by g. This just means divide. So I have f of x is 6x to the 4th plus 7x cubed minus 3x squared over 2x to the 6th plus 3x to the 5th. I'm going to divide by 3x squared plus 11x minus 4. And dividing, we can multiply by the reciprocal, so we'd like to flip this around. Well, we can turn it into a fraction by putting it over 1. You can always divide anything by 1. That doesn't change anything. Oh, so that makes it clearer when I flip it around, when I take the reciprocal. 3x squared plus 11x minus 4 ends up in the denominator, and you've got nothing, or just your fill-in-the-blank 1 in the numerator. Excuse me. The other fraction doesn't change. Again, this is going to be a nightmare unless I factor and hopefully cancel things out first. Up top, I notice that all of these terms have an x squared in common. Not a number, because you can't divide 7 by anything other than 1 and 7. You can't divide 6 and 3 by that. So we'll just take out the x squared for now. Over 2x to the 6th. Ooh, nice. In the denominator, I notice that we can take out an x to the 5th. So I'd be left with 2x plus 3. Okay, to multiply these guys, let's see. I need two numbers that multiply to 3x squared, so let's try 3x and x. Multiply to 4, so let's try 4 and 1. This gives me 4x. This gives me 3x. That doesn't add up just to 11x. Let's try maybe the 1 here, the 4 here. I've got x. I've got 12x. Oh, that'll work if the 12x is negative and the 1x is positive. Okay. So I'm done factoring the fraction on the right, but this fraction on the left, we got to figure out how to get the 6x squared. So that'd be 3x and 2x. To get the 3, maybe a 3 and a 1. This would give me 6x here and 3x. That doesn't add up to 7x, so let's try maybe 1 and 3. That'd be 9x and 2x. Oh yeah, that'll work. We need the 9 to be positive and the 2x to be negative. In the denominator, we're now done factoring because every factor is linear. If you're not convinced, x to the 5th is the same as x minus 0 to the 5th, right? 1x minus 0 is clearly linear. I'll change it back. So this is just x to the 5th. And this is 1 over 3x plus 1 times x minus 4. Let's clean it up. Okay, does anything cancel out? Yes, thank goodness. Otherwise, this was going to be nasty. 3x minus 1. I'd like to cancel that out, but they're not actually quite the same. The 2x plus 3 is the same in the numerator and the denominator, so those will cancel out. And this x cubed and x to the 5th, well, that means x times x times x, and x times x times x times x times x. So clearly, 3 of these guys will cancel. So that leaves me an x squared in the denominator, and all of these guys cancel out from the numerator. It wants our answer in standard form. So we're going to have to multiply these out. What do we have left up top? Just a 3x minus 1 in the numerator. What do we have in the denominator? This 3x plus 1 times x minus 4, which we had to factor in the first place. It just was 3x squared plus 11x. Ah, no, agony. This wouldn't be plus 11x because this would be minus 12x plus 1x. That would be negative 11x. We got to switch our signs here. This would be a plus 4 and a minus 1. And if we change this to a plus 4 and a minus 1, well, that works out nicely. Then my 3x minus 1s do cancel out after all. So we're left with nothing up top other than just a 1. And the only thing we have in the denominator is x plus 4. If we had anything else, we'd have to multiply it since we want our answer to be in standard form. Let's also list out our restrictions of the function. We'll look at the unsimplified version. We can see x can't be 0. That'd make that 0. X can't be negative 3 halves. If you're not sure, set 2x plus 3 equal to 0 and solve. X can't be positive 1/3. X cannot be negative 4. So here is our final answer.